A supernova is an incredibly powerful and dazzling explosion of a star, representing the most massive explosion that humans can witness. The aftermath of such an explosion can result in either a neutron star or a black hole, two of the most exotic objects in the universe. At its brightest, a supernova can outshine an entire galaxy and might even be visible during the day. It can take months for its brightness to fade. The explosion expels material several times the mass of the Sun at speeds reaching a significant fraction of the speed of light. In our Milky Way, we expect about 2 to 12 stars to go supernova every 100 years. However, we haven't seen one in our galaxy for centuries, meaning we're overdue for an exciting supernova show in our skies. Supernovae are truly captivating phenomena. So, let's embark on a journey to explore the stars in our Milky Way that are destined to explode in spectacular supernova events. Welcome to Curiosity Unleashed. It's time to delve into the mysteries of space. Even if a supernova were to happen on the far side of our galaxy, we could still detect it thanks to the powerful telescopes we have today, which can see incredibly far and faint objects. Predicting when a star will go supernova is really challenging because it's hard to tell which stars are in their final fusion stages and which have millions of years left. There are two ways a supernova can happen. One way is at the end of a star's life, especially if it's at least 8 times the mass of our Sun. When the fusion process inside the star stops, it can't fight against gravity anymore, causing its core to collapse suddenly and leading to an epic supernova explosion. This type of supernova is called a core collapse supernova. Many of the close or well-known stars fall into the category of stars that can undergo a core collapse supernova. Many familiar stars fall into the category of those likely to undergo a core collapse supernova. Starting with a massive blue star Spica, it's the brightest star in the Virgo constellation and one of the 20 brightest stars in the night sky. Unlike most stars, Spica is egg-shaped rather than spherical and is located about 250 light-years from us. Another notable star is the red supergiant Betelgeuse, one of the most famous stars predicted to go supernova. Betelgeuse resides in the Orion constellation, approximately 400 to 500 light-years away. There's also the red supergiant Antares, the brightest star in the Scorpius constellation. Often called the heart of the Scorpion, Antares is the 15th brightest star in the night sky, located around 550 light-years from Earth. Another red supergiant expected to go supernova is VV Cephei, located in the constellation Cepheus, around 5,000 light-years away. VV Cephei is a binary star system that includes one of the galaxy's largest stars, with a diameter similar to Jupiter's orbit. Next, we have the yellow hypergiant Rho Cassiopeiae, in the constellation Cassiopeia. This star is approximately 3,400 light-years from Earth, but can be seen with the naked eye because it shines over 300,000 times brighter than the Sun. Yellow hypergiants are incredibly rare, with only a dozen known in our galaxy. Lastly, there's a notable star in the Gamma Velorum system. Located in the constellation Vela, Gamma Velorum is a group of 4 stars. These multi-star systems often appear as a single star to the naked eye because their individual stars are too close together and distant to distinguish separately. Gamma Velorum is one of the night sky's brightest stars, situated about 1,100 light-years from Earth. One of the 4 stars in the Gamma Velorum system is a Wolf-Rayet star, which is the nearest and brightest of this rare type. Wolf-Rayet stars are known for being incredibly hot and turbulent, with surface temperatures ranging from 20,000 to 200,000 Kelvin. To give you an idea, our Sun's surface temperature is only about 5,772 Kelvin. This extreme heat makes Wolf-Rayet stars thousands of times brighter than our Sun, and their diameters are several times larger. With only a few hundred of these stars known, they are exceptionally rare. Among these, 4 stars in the Milky Way belong to a special subset of Wolf-Rayet stars that have dominant emission lines of ionized oxygen in their spectra. These stars are all predicted to go supernova within the next 1,000 years. The second type of supernova occurs in binary star systems. Unlike our solar system, which has just one star, most stars are part of binary systems, where 2 stars orbit around each other. When a star with a mass similar to the Sun compresses into a volume the size of Earth, it becomes a white dwarf, a superdense, extremely hot remnant of a star that once burned brightly. The white dwarf's intense gravity pulls material from its companion star in the binary system, causing it to accumulate mass. As this mass increases, the pressure and heat also build up until the white dwarf reaches a breaking point, resulting in a nova explosion, a powerful blast akin to a hydrogen bomb going off in space. Identifying binary systems with a white dwarf on the brink of going supernova is incredibly difficult. Any such system where a white dwarf is accumulating mass will eventually explode, but predicting the timing is tricky. The closest known supernova candidate of this type is Betelgeuse, located about 150 light-years away, making it the nearest potential supernova in the future. However, it could take up to 1.9 billion years for the white dwarf to reach the necessary mass for a supernova. Another example is Scorpii, one of the 10 known recurrent novae in our galaxy. Recurrent novae are stars that undergo periodic eruptions, typically every few decades. This cycle happens because after each explosion, the companion star in the binary system continues to transfer material to the white dwarf, starting the process all over again. The most recent outburst of Scorpii occurred in 2022. It is situated near the northern edge of the Scorpius constellation, around 64,000 light-years away. Another notable recurrent nova in our galaxy is T Coronii Borealis. This system stands out because it is expected to go nova anytime between now and September 2024. This upcoming nova explosion is significant because it will be visible to the naked eye. The T Coronii Borealis system is located in the constellation Corona Borealis, also known as the Northern Crown, approximately 3,000 light-years from Earth. The T Coronii Borealis system features 2 notable celestial bodies, a red giant nearing the end of its life cycle and a white dwarf, the core remnant of a dead star. When this system undergoes a nova explosion, it will appear in our night sky as a bright new star, comparable to the North Star Polaris. This new star will be visible to the naked eye for several days before it starts to fade, and with binoculars, it could be visible for up to a week. NASA has described this event as a once-in-a-lifetime chance for observers in the Northern Hemisphere, due to the rarity of such binary systems where a white dwarf accumulates mass from its companion. The T Coronii Borealis system is known for its recurrent novae, with the last eruption recorded in 1946. The next eruption is anticipated around 80 years later. Bradley Schaefer, a former professor of physics and astronomy at Louisiana State University, has researched historical records of these eruptions. He found that German monks documented an event in 1217 as a signum mirabile, a Latin for a wonderful omen. Additionally, English astronomer Francis Wollaston recorded another sighting in 1787. Schaefer's findings were recently published in the Journal for the History of Astronomy. Predicting the exact time when T Coronii Borealis will erupt is difficult. Current calculations suggest the nova could occur anytime between now and September. Once it happens, the new star will reach its brightest point within 24 hours. Schaefer has mentioned that it could potentially happen tonight, but it is more likely to occur within the next few months, and very likely before the end of summer. The prediction of nova events is tricky. However, scientists can study recurrent novae, which are stars that expel material periodically. By determining these periods, scientists can estimate the timing of future explosions. Merritt McGregor, an assistant professor in the Department of Physics and Astronomy at Johns Hopkins University, explains that typically, It takes thousands of years for a white dwarf to gather enough mass to trigger a nova. However, the white dwarf in T Coronii Borealis seems to do this much faster, within just 80 years, making it unique. Additionally, scientists monitor for signs such as dimming. The system dimmed for a year before its 1946 eruption and started dimming again in March 2023, leading to predictions of another nova between March and September 2024. Studying these binary systems allows scientists to better understand mass transfer between stars. For those fascinated by astronomy, events like these are a rare spectacle. Are you excited about this upcoming celestial event? Share your thoughts in the comments and subscribe to our channel for the latest updates in space exploration. Don't forget to hit the bell icon to stay updated. Let's keep exploring together.